naming monatomic ions. So we can have monatomic cations or anions, and we're going to learn how to name them. So we'll start with the easy ones. Monatomic cations. They have the element name plus the word ion. So Mg2+. Mg is a symbol for magnesium, and it's got a charge. So this is magnesium ion. If we look at magnesium, what group in the periodic table is magnesium in? Group 2. And that tells us what about the charge? Has a +2 charge. So in the name for the ion, we don't have to indicate what the charge is, because all we have to do is look at the periodic table and we know what the charge is. These names the system was designed to be efficient, so we're not writing a lot of extra stuff, and to be consistent. So everybody does it the same way. Well, most of the main group elements only form one cation. So those are the ones we learned about. Group 1A, Group 2A, Group 3A. They only form one kind of ion, and so we just name them with the element name plus the word ion. But the transition elements aren't so good at following patterns, and a lot of them can form more than one ion. And so we have to specify which one we're talking about in the name. There's two different systems, the stock system and the Latin system. So the Latin system is an older system, and they use the Latin element name with an us or an ic suffix. And I'm telling you about that because it is still used sometimes. I haven't watched much TV for a while, but they used to advertise toothpaste all the time. And, oh, our toothpaste has stannous fluoride in it. It's good for your teeth. Stannous. That is a particular ion of tin. Did you know there was tin in your toothpaste? That doesn't sound so nice, does it? Nobody likes to suck on tin. Ugh. Gives me the heebie-jeebies just thinking about it. Tin ion is very different than tin metal. So you'll see this system, and I just want you to know the us or the ic is telling you the charge. But I'm not going to make you learn that system. We're going to use the stock system. Stock is the preferred system. It's the one you need to know. It uses Roman numerals. So we use a Roman numeral to tell the person reading the name what the charge is. We specify the charge with a Roman numeral, and we put the Roman numeral in parentheses. So the example here, Fe3+. If we find iron on the periodic table, it's in that middle section, the transition metals. We can't predict what its charge is just by looking at the periodic table. Turns out iron can be +2 or +3, depending. How do we know which one? This is Fe3+, it's named iron 3 ion. So the 3 is in Roman numerals in parentheses, and there's no space between the end of the element name and the parentheses. Word hates that. It is always doing that underline thing, telling me I forgot the space. I wish I could educate it, but I can't. Let's just have a really brief review of Roman numerals. 1 is I, 2 is 2 capital I's, 3 is 3 capital I's. If they kept that up, it'd be just really tedious, wouldn't it? It's not even as good as tally marks. Well, 5, don't ask me why, 5 is capital V. And 4 is 1 less than 5. It's the number before 5, so 4 is 1 before 5. And 6 is 1 after 5. And 7 is 2 after 5. And that's about as far as we have to go. So those are the Roman numerals. So this part right here is important. Not that everything I write isn't important, but that one's like extra important. Metals in group 1A, 2A, 3A, plus zinc, silver, and cadmium always form a single charged ion. They only form one kind of ion, and so we don't use Roman numerals with those guys, because we can tell their charge from the periodic table. Group 1A, 2A, 3A, zinc, silver, cadmium. And I'll repeat that multiple times. If it's not one of those, you need to use a Roman numeral. I think most students would prefer that we just use Roman numerals all the time, because then you wouldn't have to remember which ones. But we don't like writing Roman numerals if we don't have to. So here's a great table from your book showing different ions. And what I want to point out to you is this triangle here. So there's aluminum, gallium, and indium. What group are they in? 3A. So I'm going to remove the highlights so you can see it better. They all have a +3 charge. And there's 3 of them. And the way I remember these guys is I think about going downstairs. So here's aluminum +3. If I go down 1, I go down 1 in charge. This is zinc 2+. And here's silver 2+. So we've got this little triangle, and there's 1 with a 1+, and there's 2 with 2+, and there's 3 with 3+. There's a little triangle in there. Gallium and indium are easy because they're in group 3, but we don't run into them much in general chemistry. So the ones you'll see the most commonly are silver, zinc, and aluminum. Cadmium we'll throw in there occasionally just to be interesting. And then these guys, group 1A, all +1. Group 2A, all +2. And then we learned how to count backwards from the noble gases to find these. So these are the ions whose charges you predict just by looking at the periodic table. Any questions? So if the metal that you're naming is one of these guys that's shown on this table, you don't use a Roman numeral. If it's not one of these, you do. Oh, look, I did that. Okay, what about the nonmetals? Well, the nonmetals form negative ions. Nonmetal, negative, anions. And we can predict their charges from the periodic table. When we name them, we change the ending of their name. So let's think, and chemistry land is a very, very traditional place, okay? So it's not very modern at all. But traditionally, when a man and a woman got married, who changed their last name? The woman. The nonmetals in chemistry land are feminine. When they form a compound, when they become an ion, they change the ending of their name. Do the guys change their name when they get married? No. Do the metals change their name when they get married? No. Well, metals don't get married. When they form a compound. Forming a compound is like getting married. So we're changing the ending of their name to "ide." So Br is bromine. When it's an ion, it's bromide. Chlorine becomes chloride. Oxygen becomes oxide. What happened to the YG? I don't know. Oxygide sounded dumb. There's some little exceptions in here. Phosphorus is phosphide. And sulfur is sulfide. So we're taking the ending of the name, changing it to "ide," adding the word ion. That's how we name the nonmetals. Predicting formulas for the monatomic cations. Kind of already covered a lot of this. The ion formula, the formula is the shorthand. It's just the element symbol with the charge written as a superscript on the right side. And yes, it matters. It has to be a superscript, which is above, like Superman flying over the city. And we have to include the charge. The sign is always written but it's written after the number, not before. The number 1 is not written, but the sign plus or minus is. 4 ions in groups 1A, 2A, 3A, and zinc, silver, and cadmium. We know what the charges are. These 1A, 2A, 3A we find in the periodic table. These guys we memorize. There's a little pattern in the table. And any other monatomic cations get a Roman numeral to tell us what the charge is. So predict the formula for the following monatomic cations. Barium ion. Well, what's the element symbol for barium? Ba. Oops. Ba. How do we predict the charge for barium? It's in the second group of the periodic table, so its charge is 2 plus. Metals form plus ions. How about cobalt 2 ion? CO. And here, size matters. It has to be a small o. Because that's cobalt. This is carbon monoxide. There's a difference. One's a metal, one's a poisonous gas. So, people get upset when doctors write prescriptions wrong. Things like this could kill you. Punctuation saves lives. Did you know that? Let's eat grandma or let's eat grandma. That comma makes a big difference. And is it worth less or is it worthless? There's a space in there. It makes a difference. So size is important. Make sure that I can tell, is that a small o or a capital O? Thankfully on exams, they're multiple choice, and so we don't have to worry about handwriting, but just practice. So that's the symbol for cobalt. What's the charge on the cobalt ion? 2 plus. Because the Roman numeral 2 tells us. Cobalt is a transition element. We can't predict its charge because it also forms another ion. I think it's 4 plus, but I can't remember. How about aluminum ion? Al 3 plus. I write my lowercase l's like that because look at that. What is that? Is it a 1? Is it an I, capital I? Is it a lowercase l? Hard to tell. This is an I, this is a 1, this is a lowercase l. So that's just what I do. Aluminum 3 plus, 3 because it's in group 3. How about zinc ion? Zn 2 plus. Why 2? Yeah, we'll take a step down from aluminum. That's zinc. We kind of memorize that one. Any questions? Predicting formulas for monatomic ions. Nonmetals form anions by gaining electrons. So we can predict the charges by counting backwards from the noble gas group until you get to the element you need. Group 7 is going to have -1, group 6 -2, group 5 -3. So fluoride ion. Fluoride comes from what element? Fluorine, right? And the symbol is F. Sometimes people put Fl. There is no Fl on the periodic table. It's just F. What's the charge of a fluoride ion? -1. So the charge is -1, so I just put a negative sign. Don't need the 1. How about nitride? And 3 minus. So neon is 0, fluoride's -1, oxide is -2, nitride's -3. How about phosphide? P 3 minus. Okay?